Hi, Jeff Disher here again. Today I'm going to talk about files and disks. Basically just explain what a file is and what a directory is and how the disk is made into a logical structure by a file system. And later on I'll get into a different talk about file system corruption and fragmentation. So this is mostly background. So first of all, files. The files are the underlying storage for just raw chunks of data. So you want your word processor, you want to save a document, it'll put that together into some chunk of bytes that it puts into a file on disk. So the file contains that information. And a directory is something which is a special kind of file, which is the one that contains other files and directories. This is something which is implemented by the file system, and applications themselves don't really interact with these. Well, they don't change them, but they use them to find things. The name extension idea, like .txt, .mov, whatever, those are just a convention. They don't really mean anything to the file system itself. The file isn't changed by you changing that extension. The file, it stays the same, now you might just confuse other applications. So other pieces of information that go along with the file, things like its name, permissions which users can access it, and things like when it was last opened, when it was created, and all that. That's usually not stored in the file. It could be stored in kind of a side structure. One way or another, it's not stored in the data that's being interacted with by the program. So from its point of view, those things aren't part of the equation. Now, to get onto disks themselves and how file systems are structured over this. Now, really, a disk is just a list of raw data. The file system, when it sees it, it just sees a list of data entries. And it is how the disk is interpreted into the hierarchical file system you interact with from the application. So there's no one way to do this. It's something that historically there's been countless ways of approaching this, and people still come up with more today to solve new problems or to better solve old problems as new realities change. So for example, you'd run into something on Windows that would be like a FAT32 or an NTFS file system. The one used on Macs is called HFS Plus. It's an old one that they keep kind of revamping incrementally over time. And on Linux, there's all sorts of them that people use commonly. Usually it's one of the EXT, the extended file systems. 4 is the one they're up to now. RiserFS is a popular one as well. Same with XFS. There's others, JFS, things like that. So in terms of what a file system looks like, this is going to be a really basic example of just how some of the organization works. Not a lot of the file system metadata itself, the things it uses to remember more complex or implementation-specific pieces of information. So the file system looks at a disk like this. It's just a big list of data entries. These ones labeled from 0 to 13. Now, one thing to keep in mind is that each of these blocks here is actually the same size. It's used because that's how you interact with the underlying disk. Also, it makes it easier to organize things. So first we're going to start out with, at the beginning of the disk, you're going to have something which is the root directory. In this case, we're going to call it slash, so it's called in Unix systems, and that's going to be at index 0 in the list. Now this directory will contain information describing other files that you have on the file system. For example, this one says, oh, there's something called file1 at index 12, and there's something called dir at index 5. The one at index 5 is another directory. This directory, it talks about something called file1 at index 1 and file2 at index 13. Now the thing that's interesting here is there's two files here called file1.txt, but because they're in different directories, they don't collide in any way. So you can have multiple files with the same name all over the place, but as long as their containing directory only sees one file of a given name, it can know which one to talk about unambiguously. And that's usually the only restriction you end up with these things. So now to use this example, assuming you had a file system laid out this way, if a program wanted to access, say, /dir /file1.txt, it would start by first reading slash and saying, okay, so at index 0, read this directory, find out where dir is, because that's the next thing it's looking for based on the path name. And when it reads the dir at 5, it'll find, okay, I need to look for file1.txt now. All right, well that, as we talked about earlier, is at index 1. So then it'll know, all right, when I'm reading this data, when I want to read this file, I now know that it's index 1 I'm reading. From that point on, it doesn't worry about things like the path itself or how it got there or other file system data. For the application's point of view, all it needs to know is, great, now I've got somewhere I can read and write data. And so that's really the abstraction that a file system provides. It means that applications don't have to worry about how the disk itself works, how the disk is organized, or even how you want the file system to work. Because otherwise, all the programs have to agree on how to not get in each other's way when they're trying to organize data on the disk. The file system gives them this common dialect of how to describe the structure. Also, the file system is part of the operating system, so it actually can make sure that the programs don't step on each other or corrupt each other's data. It is implemented in such a way that it keeps them all separate, and it makes sure that they don't break any rules like, oh, I want a file that's 10 bytes long and then it writes 15 bytes and overwrites something. It manages all this so that the applications don't corrupt each other's data and they don't have to worry about the underlying details. So that's just sort of a basic primer on how this stuff works, how files and directories interact, and how file systems give structure to the otherwise raw data of the disk, which is just a list of stuff. So what I want to do as a follow-up is talk more about file system corruption and file system fragmentation, which are two things people have probably heard of, but they don't really know what they mean. So I want to go into detail on those in a later talk. But for now, this is a basic starting point. Anyway, send me an email if there's any questions or comments or anything else you want to hear me talk about, and I'll put something together. Anyway, talk to you later. Bye.